Hello, everyone. Good morning, good afternoon, or good evening, depending on your time zone. Great to have you in our YouTube stream today. And we continue the SAP Cloud Lifecycle Management webcast series. The purpose of the SAP Cloud Lifecycle Management webcast series is to provide you an information and share the knowledge on various aspects of SAP Cloud Lifecycle Management and, of course, various specifics that are connected with them. Today, we will talk about Software Update Manager. This is already the set session on this topic, and today we will deep dive on the specifics of the conversion to SAP S/4HANA. Our speaker for today is Boris Rubert, who is product manager in the SAP Cloud Lifecycle Management team. My name is Larissa Brinkman from the SAP Global User Groups organization, and I'm your host for today. We kindly ask you to place your questions in the live chat, and we will answer them at the end of the presentation. The replay will be available under the same link immediately after this session, and I will also provide additional links during the sessions in this session in the chat. With this, I wish you great interaction and kindly ask Boris to take over.
Thank you very much, Larissa, and warm welcome from my side as well. As you have heard, my name is Boris. I work as a product manager on the Software Update Manager and on system conversion topics. Today, it is about the SAM tool, the Software Update Manager, as the tool, as the engine to execute the system conversion to SAP S/4HANA. I presume that you have already knowledge about the Software Update Manager in general. For example, you have listened to one of our previous sessions. Well, as already announced, this is a session as part of the Cloud and Lifecycle Management webcast series. You see the URL where you find all the sessions listed. I have listed an extract for today. We are here in the middle on the Software Update Manager, the tool for system conversion to SAP S/4HANA. There are additional sessions on the SAM tool and on system conversion topics, and this is only an extract. There are additional sessions in the CLM webcast series, and please check the webpage to find the latest dates on those sessions. So, yeah. What do we have here? We have three sections again. First of all, on the Software Update Manager in the context of a system conversion. What kind of tasks does this tool execute? What options are available? What kind of checks are executed? Then we'll have a look on what we call the data conversion as part of the overall system conversion. And finally, for most projects, reducing the downtime is an important task. So we'll focus on that in the third section. But first of all, Software Update Manager, it is the engine to drive the technical conversion from SAP ERP to SAP S/4HANA. I presume as well that you have a general understanding what a system conversion is. So overall, the transition to SAP S/4HANA can be done by three different transition scenarios, from which the system conversion is one, where we have one ERP source system, which is completely converted to SAP S/4HANA. So as a reminder, there are different steps in this project, system requirements to be clarified. The maintenance planner has to be used to plan the actual conversion, to provide the software archives. The simplification item checks have to be clarified before starting the Software Update Manager. Custom code preparation or adoption is an important topic. We just focus on the realization phase, the Software Update Manager here. So what kind of tasks does the tool has to do? First of all, obviously, software update. That's the name of the tool, Software Update Manager. So provide new applications and new components and by the way, new tables as part of the conversion procedure. And the other aspect is data conversion. So what do we understand under this term data conversion? And the system conversion transitions an ERP system from the existing, for example, table model, data dictionary model, to SAP S/4HANA, where a new data model is existing and new tables are established with SAP S/4HANA. So the table content has to be transferred from the previous old tables to the new tables of the data model. And this is especially executed partially by the software update manager, as we will discuss in the second section. You see a simple illustration picture here. So assuming that the source system is already on the HANA database, which is not a requirement for the system conversion, but it's a possible starting point. Then from the architectural point of view, we have a database host where the database, SAP HANA database, is located. And we have the primary application server host on which the primary instance, where we call this central instance, is running, where we typically extract and start the software update manager as such. Of course, it's possible to have additional application servers where you may consider to run the software update manager as well. This illustration shall indicate that the reason why we call this an in-place procedure, from the perspective of the software update manager, the database host and the application server host is kept. So it's in place. We reuse the hosts and the application server. That's the illustration here. As mentioned, it's also possible that the ERP system is not yet running on HANA database. That leads to a different architecture picture. So in this case, if the source is not yet SAP HANA, then of course we have to provide a host with the HANA database installed. And we nevertheless start the software update manager on the application server host, typically primary one. And the procedure as such is still called an in-place procedure, as the application server host is not changed. We obviously changed the database and the database host, but from the application server perspective, we still call this an in-place procedure. And in this case, source not yet on HANA database, then the software update manager will have to carry out the database migration. And this is done with what we call DMO, database migration option, as a feature in the software update manager to also migrate from non-HANA to HANA database, if it's required. As we are in this discussion of the architecture view, and we call this in-place procedure, it's worth mentioning that there is a separate case where the software update manager offers what we call DMO with system move. DMO with system move means we do not only change the database host if the source is not yet HANA, but in the project, we may have good reasons to change the application server level as well, as we would like to introduce new hardware as part of the downtime, or we would like to move the system from one data center to a different, or we would like to move the system from on-premise to a hyperscaler infrastructure as a service. Then DMO with system move would be the approach that the software update manager offers. So we start the procedure on the source and we combine the system conversion with a move to new hardware where even the application server level is changed. So in this third illustration, we do no longer call this an in-place procedure, but this is the procedure where we can also change the application server host. We will have a look at this DMO with system move after the following slide. That is a kind of introduction, what kind of tasks the software update manager does have to fulfill. Now let's have a look what the prerequisites are before we start the software update manager as part of the realization in such a system conversion project. Of course, we have to use the maintenance planner, because this maintenance planner will provide the software archives and the stack XML, this file that is a kind of recipe for the software update manager. The software update manager will ask for this on the very first dialog. So maintenance planner has to be executed. The maintenance planner, as you know, will check the source system, whether it's capable to be converted on component level and business function level. And only if this check is green and you have the license for SAP S/4HANA, then the stack XML will be provided. Of course, you have to consider the simplification item checks as well, where we strongly recommend you to run the simplification item checks in the source system prior to starting the software update manager. The tool will start exactly the same checks, and if there's an open issue, the software update manager will stop and block the conversion. So you have to solve all issues beforehand to not run into issues during the execution of the software update manager. These are the required prerequisites for starting the software update manager. Optional activities, well, depending on the system type, we strongly recommend you to use the SAP readiness check as a comprehensive tool that includes a lot of different checks, and you should use the SAP readiness check very early in your project to get a good understanding on all those required adaptations that may come into play. So it's strongly recommended, but the software update manager will not ask you whether you have done the check. So that's why it's optional. Well, custom code check can be ignored. You can start your first sandbox conversion without considering the custom code adaptation, since you check your custom code, but you adapt your custom code after the conversion, which would be typically done on the converted development system. So custom code check is not a prerequisite for the software update manager. And something we would like to emphasize as well, highlighted on following slides as well, is that the software update manager offers a prerequisite check extended. That is a helpful option to find out about potential major blockers before starting the actual conversion. Again, explained later, and the conversion guide contains, of course, the explanation for this prerequisite check extended. These are the prerequisites before starting the software update manager. And now let's come back to this specific case that we do not want an in-place procedure, but we would like to combine the system conversion with a move to hyperscaler, for example. So DMO with system move. It's a use case to move to complete SAP system as part of this system conversion. So you can migrate to cloud in the sense of infrastructure as a service, hyperscaler. And this is especially relevant if you are targeting SAP S/4HANA Cloud Private Edition as part of the RISE with SAP program. Then you do have your ERP source system on-premise, and you would like to have the SAP S/4HANA on-premise software running at a hyperscaler, and that is what we call SAP S/4HANA Cloud Private Edition. Then DMO with system move is being used typically by an implementation partner that will execute this. What I would like to focus on here is that there is a parallel mode that we strongly recommend. So you should be aware, and the partner should be aware of this as well. The procedure DMO with system move consists of a part where we start the software update manager in the source landscape. The tool will trigger the R3 load to export the tables from the source database to folders, to dump files, and then we copy the software update manager directory to the target environment. You may have seen the illustration there, the animation, and we continue the procedure in the target. And there it's strongly recommended to use what we call the parallel mode, because then those two software update managers can run in parallel, and this allows you to reduce the downtime drastically. Very important. Since in the target environment, the software update manager will set up what we call the shadow system with shadow repository. So the repository objects already on the target level. And these are long-running activities, generation of ABAP load as well. And only if you use the parallel mode, then those activities in the target will happen while the source system is still up and running. Very important. That's why we strongly recommend use the parallel mode. There are 3 sync points where you will have to copy the SAM directory to the target as an initial step. The whole phase host change move SOT tells you to do this. Then there is the downtime dialog in the source where you do another copy, and then there is another phase specific for DMO system move called host change stop. Also, this dialog tells you now that's the final point where you synchronize the data. These are 3 points in time for manual synchronization, but there is even a possibility if a source and target are running on Unix operating systems or Linux, then you can use a script delivered by the software update manager to have a continuous synchronization to even reduce the downtime. Then also export in source and import in target are running in parallel. That is a big advantage. That's the strong recommendation. Use the parallel mode if DMO with system move is used, for example, as part of the RISE project where you move your on-premise system and convert it to S/4HANA Cloud Private Edition in a hyperscaler. You see 2 links here. The first one is explaining DMO with system move and the reason why you should use the parallel mode again. The second one is a kind of outlook. We currently evaluate other possibilities apart from DMO with system move to do the transition to SAP S/4HANA combined with a move to a hyperscaler. So that's worth considering as well. Again, that's a pilot phase where we currently evaluate this with accepted pilot projects. That was a sidestep with DMO to system move. That is the exception where we do not have an in-place procedure. But now I would like to come back to the software update manager in general and this prerequisite check extended that I've already advertised. So the prerequisite check extended is a good starting point. It's not required, but we recommend you to consider this. Let's see how a real conversion run, if you start on Sandbox, may look like. We start, of course, with the maintenance planner. The tool is providing the stack XML, the software archives. Then you start the software update manager, and you may run into the first issue. The tool tells you either operating system or database level is not sufficient. That means stop, you have to fix this. This takes time. Only then you continue the procedure. You may run into the next issue. There are inactive objects in the ABAP world. You will have to fix this, takes time. Only then you can continue. And finally, the tool will run the simplification item checks and will detect there are open issues. That's a blocker that you have to work on. So you stumble from one issue to the next one. You do not know how many issues there will still be afterwards. And so instead, we recommend you to use the same stack XML from Maintenance Planner, same software archives, but on the user interface of the software update manager to select the prerequisite check extended. That's important, extended. And with this, the tool will, of course, do the same uptime phases, will do the same checks, but the advantage is now you can ignore those major issues. Ignoring means they are listed in an internal list. The tool will show you this list. It's available on the user interface. The tool will not enter downtime. It will not execute the conversion, but you will see the list of all those blockers. And afterwards, you can run your project parts, you can execute the solving of those issues in parallel without the need to wait for one aspect to be finished to start the other. That's the big advantage of the prerequisite check extended. It's offered on one of the first dialogues here, what we call scenario strategy. And there is even a check that you can run if the HANA target database is not yet provided. Only for the case that the source is not yet running on HANA database, then you may even start very early with a reduced scope of checks, but nevertheless, that would be a starting point. Now, you know the maintenance planner, and the maintenance planner is responsible for providing the stack and the software archives. How about if the maintenance planner does not allow to calculate those software archives because there's an add-on blocking or a business function? Even then, you may execute the prerequisite check extended. That's the second slide on the prerequisite check extended. The maintenance planner may offer a specific check stack. So in the dialog where the result of the check as the first part of the maintenance planner is displayed, in this case, there is a block. In my case, there's a business function not supported. You nevertheless may continue in check mode. So the maintenance planner will provide a specific check stack XML and the software archives. And if you now start the software update manager and provide the link, the location of this specific check stack, the software update manager will directly start the prerequisite check extended. So there's no option to execute the real conversion, only the prerequisite check extended is allowed. But this allows you in a phase where you may have to solve issues with add-ons or business functions to nevertheless already find out the major blockers, get the list from this prerequisite check extended. That's the big advantage. It's the same illustration here. Collecting those major issues, you may ignore them, they are put to the list, and you know afterwards what to do. This is the advantage. Now, on a high level, what kind of blocks are executed by the software update manager? So the main technical conversion steps. You see this illustration here in green. This is the uptime processing. That means end users are still working on the system. This is much longer than shown here on the slide, several days maybe. And in this time, the software update manager will already create what we call the shadow system, shadow repository. So there are already activities in uptime to reduce the downtime. And then finally, we decide to enter the downtime, and the database migration will happen. Of course, only if it's required, only if the source is not yet on HANA database. The database migration from non-HANA to HANA happens. Then the update part will be executed. So new software components, updated software components. And then what we call the data conversion will happen, which is partially executed by the software update manager and partially to be executed afterwards. So after the software update manager is finished, the system is not yet completely converted. There are still data conversions to be executed, as we will discuss in the second section here. So that's the outlook. Nevertheless, it's worth spending some words on terminology. If you talk about downtime, be specific which part you are referring to. The software update manager has a technical downtime where those activities are executed. But the technical downtime is longer as the fin data conversion is also downtime. Although the ABAP system is running to execute this fin data conversion, end users cannot yet work with the S/4HANA system. So that's technical downtime. And for you, the business downtime is the overall downtime that is relevant in the project discussions. So from ramp down to ramp up, including regression tests, business validation, that is business downtime. So whenever you talk about downtime and downtime reduction, be specific which part you are referring to. That is important. We will have a section on downtime later, but now let's first have a look on the data conversion part, and then we're going to focus on the downtime. So data conversion is already mentioned. Data conversion is moving the content of the tables from the old data model to the new data model of SAP S/4HANA. That is, for example, the table mat.doc, where the data conversion is executed by the software update manager. And there is the table AC.doc-A, the universal journal, where the migration happens in this fin and material ledger conversion. So same picture we had before, but now it's illustrated that the fin and material ledger data conversion happens after the software update manager by means of the IMG. So you will have, as a fin expert, you will log onto the system, you will start the respective IMG activities and execute this. First, the fin customizing on the new level, then you execute the fin data migration, and then some post activities. The discussion on downtime we already had. But now there is one additional aspect that you see here, and that is after the complete downtime is finished, we see a block in green called SDMI. What does it mean? Well, let's have a look on the title of the slide, SDMI, Silent Data Migration Infrastructure. So this is a data conversion part that is executed after the downtime. So there are some conversion routines that are executed after you have your system already on SAP S/4HANA. And those data conversion activities will prepare your system for the next upgrade. So they are executed in uptime. That means end users are working on the system. It's happening in silence, so end users do not see, are not affected by this conversion. And so only after the conversion, before you start later on, a month or years later, the upgrade to the next release, this data conversion has to be finished. There are some jobs scheduled in the background that will execute this, and that's why we call this silent data migration. It's put to uptime after the conversion and not put into the downtime to reduce the downtime. That's the general idea. And again, those conversions to new structures are not affecting the usage of the S/4HANA system. They are just a preparation for the next upgrade. That's the good part of the story. Now, a short look on this Fin data conversion activities in the IMG. This is a screenshot of the IMG activities where there are some preparation activities, Fin customizing. And then there's one entry called Start and Monitor Data Migration. So that is a transaction here in the system where you or a Fin expert will trigger this conversion. There are steps here to be executed, and you will have to consider that this all works out. In your first conversion, you may experience issues there. If you have the sandbox, a copy of the productive system, there may be some inconsistencies that you will fix, especially in the productive system, so that in the end, this data conversion to the Fin new tables will work out without issues. That's the general story. Not activities triggered by the software update manager, at least not in the standard approach. We will have a word on this later in the downtime section there. Now, I told you about those silent data migration jobs that are running after the conversion is finished. They are running in the background. And there were some feedback from customers and partners stating, we do not want this procedure. For us, the downtime is not as critical, but we do not want any background jobs to change our business data. That's why we introduced an option in the software update manager to decide to execute those silent data migrations, not after the conversion, but as part of the downtime. So the silent data migration concept has the benefit to avoid downtime by executing those activities after the conversion, but there were some concerns also from audit perspective. And that's why we have an option in the software update manager to move those jobs back to downtime. So they will be executed in some post-processing downtime. So triggered by the software update manager, those jobs will run synchronously and the tool will wait until they are finished. And that's a screenshot of the respective dialog, decision on silent data migration. You may select Zoom shall perform those silent data migrations during downtime. But this is a drastic extension of the downtime. You should consider this and, of course, test this before choosing this option in the productive run. Once again, in this illustration, we have had these blocks before. Typically, silent data migration happens after conversion, but you may decide to move those uptime activities to downtime. And if there are issues, the software update manager will stop and you will have to solve those issues before you can finish the run of the software update manager. With this, we now come to the third part concerning downtime. As typically, projects are very keen in reducing the downtime. So how can you influence the downtime with the means of the software update manager, and which additional options are available? That's now the question. And if we consider that the system conversion is taking a source system and it's converting to SAP S/4HANA, that's just an illustration. Of course, it's the same system as we know in the in-place procedure. What kind of aspects are impacting the downtime, where we know that there may be data migration if source is not yet on HANA database, and we have the data conversion by the software update manager and the data conversion for by IMG activities for Fin and material ledger. First aspect is, of course, you can imagine source database size. The bigger the database, the longer the procedure takes. The longer the migration takes, the longer the data conversion takes. So you may consider archiving first before you start the conversion. Next aspect is not only the overall database size, but also the question, how big is the portion of those tables that are undergoing this data conversion to the new data model of SAP S/4HANA, especially Fin data. If your system is extensively used for Fin area, then this may be a larger portion, and then the data conversion after Software Update Manager will take longer. Next aspect is system performance. You will extract and start the Software Update Manager on an application server host, and you may consider to even install an additional application server for the time of the conversion to run the Software Update Manager with its tools for export, import, R3 load on this additional application server that may have a better performance, even no end user working on that. That is influencing the downtime as well. And last point is quality of data are influencing the downtime. Oh, that sounds a bit strange. Well, quality of data influences downtime. Well, it's a bit tricky. The Fin data conversion after Software Update Manager will run into issues if you do the first run on the sandbox. There will be some issues due to inconsistency in financial data. Your ERP system is fine, it's consistent, but there are more detailed checks by S/4HANA. That's why the Fin data conversion may run into issues that you were not aware of. And solving those issues during the sandbox run is downtime. So that's why those quality issues will extend the downtime. But of course, you will fix those issues in the productive system, and the next copy of the productive system that is converted, those issues will not show up. So it's a bit a warning. Be prepared that the first run will take longer, but the second run is always faster. So only after the second run, you have a better understanding on how the real downtime will be and whether it's important to tune the downtime or even to consider a downtime optimization approach that I will explain in the following slides. So how can you estimate the downtime? Maybe even before you have your first sandbox run? Well, you should have your first own experiences, but there are some answers, two answers for this question. There is, on the one hand, in the SAP Readiness Check, a tile that is called Planned Downtime Calculator, where you get a first impression on how long the downtime may be for your system. That is one part. The other part that I would like to advertise is what we call technical downtime optimization application. That is an offering in the support launchpad that you can use. If you have done your first conversion run, then you have statistics. The Software Update Manager will run and write down all the statistics and provide logs that you can upload in this technical downtime optimization app. And with this, you will get a graphical illustration on the downtime. You will even get hints how to tune the procedure, and you may find that there is a simulation. What would be potentially the downtime if I switch on this or that additional approach that I will show on the following slides. So that is strongly recommend to consider those two parts for downtime estimation and analysis with the respective blog posts that I list here on this slide. Now, there are advanced technologies, but even for the standard approach, it's worth considering what you can optimize. If migration is part of the game, we recommend the DMO optimization. DMO optimization is listed in this blog post here, strongly recommended. Then database size was already mentioned. You should consider to use archiving. So you can archive parts of your source system, put them into archive. You can still use this archive once you have converted your system to SAP S/4HANA. So S/4HANA can access those archives. That's no issue. And last point here on the slide is number of background and dialog processes for the data conversion of Software Update Manager, but also for the FIN and Material Ledger data conversion. There are some SAP notes listing additional hints on tuning the standard conversion approach with the Software Update Manager. But if you experience that this tuning does not reach a downtime that is accepted by your business, by your project leads, then you may consider that there are additional approaches offered by the Software Update Manager to reduce the downtime. They are listed here on the following slide. There is the standard conversion approach that we have already discussed, to downtime parts like migration, update, and conversion, partially by the Software Update Manager and partially executed afterwards in the IMG. Now, what you may consider if your source is not yet HANA, then you may consider to reduce the migration part. Again, this part in the middle is only relevant if your source is not yet HANA. If migration is part of the game, then you may consider what we call downtime-optimized DMO. We also call this uptime migration, which illustrates fine what this approach is doing. It's doing the database migration partially in uptime already. Wait a minute, uptime means end users are working on the system. What if I already let the tool migrate large application tables in uptime and end users are changing those table entries or creating new table entries? Well, the tool is prepared. It considers those changes. There will be a data replay in uptime and a final data replay in downtime. The Software Update Manager has its own technology based on database triggers to recognize what is changed after the table has been migrated. It will replay this. So that is a way to reduce the migration part of the downtime. Again, only if source is not yet HANA, only then we have the migration. Okay, that's fine. That's a step, but you see, it's not a real big step to reduce the downtime. But we have another approach that is available as well. So you can use downtime-optimized DMO. You have a bit higher effort to select which tables to migrate in uptime. But then we have the big benefit of a drastic downtime reduction. And this is what we call downtime-optimized conversion. Downtime-optimized conversion will not only do uptime migration, if source is not yet HANA, but it will trigger the data conversion already in uptime. Wait a minute, data conversion in the standard approach was partially executed by the Software Update Manager and partially an activity after the Software Update Manager. Yes, and for downtime optimized conversion, the Software Update Manager will consider both parts. So only for downtime optimized conversion, we have activities in uptime already. And those activities that in the standard approach were IMG activities after the Software Update Manager, this is now included in the Software Update Manager. So the Software Update Manager will also execute the FIN data migration in the uptime already and will consider changes by end users with a data approach. So in downtime, we have a data migration and a data conversion. But afterwards, we do not have this big block of FIN and Material Ledger data conversion any longer. And that's the reason why we have a higher downtime reduction for this approach. Downtime optimized conversion is available for educated experts. That means you have to learn this, you have to gain a knowledge badge. Then you can use this on your own as a customer or partner, and promises on the one hand to reduce the downtime, but of course it's a higher effort because you need more test runs and you have to consider more aspects compared to a standard run. A downtime optimized conversion approach was covered in a TechEd session that I did 2 years ago. It's still available in YouTube. You may consider this if you would like to learn more about this. And as a figure in one of the very early pilots that we had a live example where there was an Oracle on with more than 17 terabyte that was executed with a technical downtime of only rough about 24 hours, including the financial conversion that's important to manage. So we have the standard approach. that should be fine for systems up to 5 terabyte as a rule of thumb. Then systems between 6 and 20 terabyte. There you may consider downtime-optimized conversion. Larger systems, there we recommend an SAP service called near zero downtime technology. So it's not a tool, it's a service that is used by experienced SAP consultants to even reduce the downtime further for larger systems. Before we are done, I just want to mention that project planning considers different aspects. You will have a copy of the productive system sandbox. You will iterate this, get familiar with the procedure. You will convert the development system and do your adaptations to be applied in the following systems by transport requests. You will do business functions and of new and adapted processes, and you will consider a dress rehearsal on the productive system. From my perspective on the software update manager, I want to make you aware of that the software update manager has its own release cycle. So every 4 months, there is a new SUM SP version available. And that means the previous version will go to a phase that we call patch on request. Patch on request means this version is no longer available for download. So a tool version that is in phase patch on request is not visible in the download area. But if you have an issue with this, you can still create an incident. And if there's a patch required, we can deliver a patch. But consider after additional 4 months, the previous available, in this case, SP11 of Software Update Manager is in a phase out of maintenance. And out of maintenance means we cannot deliver a patch any longer. And our recommendation is not to use an SP version of the Software Update Manager that is in phase out of maintenance. So you should consider if your project will run longer than 8 months, you will have a point in time where you may switch to a new SP version of the tool based on your priorities, maybe switching for dev, QA, and prod to a new version, so that you do not do the system conversion on the productive system with some SP version that is in phase out of maintenance. Yeah. That's called the maintenance strategy, and the actual timeline is attached to the central node of the respective SA toolset, which is the bundle where different tools are delivered by SAP. With this, we are at the end of this overview on Software Update Manager as the technical engine for a system conversion. Thank you very much, and I'm curious to see what kind of questions you may have.
Thank you, Boris. Thank you for your interesting presentation with all the deep dives and insights into various aspects of conversion to SAP S/4HANA. I currently can't see any questions in the chat. I was sharing a link to the readiness check blog for those who are not aware of this tool yet. And of course, I've shared in the chat that we will provide the PDF of this session in the description to this video. So I can see the first question coming in. Most S/4HANA conversion projects exceed 8 months, so we should be running several versions of the SUM.
Thank you for the question. Yes, I agree. If your project will run longer than 8 months, which can well be the case, then again, you should be prepared to switch the SP version of the Software Update Manager. Again, it's not a must. You can, if you have thoroughly tested with various test runs and dress rehearsal, you may also go and start the conversion of your productive system with an SP version that is out of maintenance. Out of maintenance means if there is an issue and you create an incident, we are technically not capable to deliver a patch for this SP version. We may force you to use a new SP version. And then it's a question of risk assessment. What's the priority decided by the customer in a project typically. And that's why we say, well, we recommend to consider to find a point in time in the project where you switch to a new SP version of the software update manager, which will be in phase patch on request, at least when then you convert the productive system. Yes, thank you.
Yes, exactly. It was also the concern of the author of this question that it might be quite risky. However, he just added to this. Thank you for the answer. And I have the next question in the chat. In parallel mode, if source is on Windows and target is on Unix, is that possibly to do that?
Yeah, that's a good point. And let me see if I can quickly jump to that slide to illustrate this important question on DMO with system move. So I advertised the parallel mode, and I told you then we have a software update manager in the source and a copy of this running in the target in parallel. And now I told you you can do a manual synchronization, and there is even a script that is delivered with the software update manager if both are running on the same operating system Linux. And now the good question is, how about if the source is running on Windows and the target is running on Linux? Then you cannot use this delivered script provided with the software update manager. But this does not mean that you cannot use the parallel mode. Yeah, and good question. That's why we have those 3 manual sync points listed here that are to be done manually then. That means the software update manager, you will tell the tool, I would like to execute DMO with system move in the source. Then there will be a dialog telling you, okay, we have DMO with system move. Now it's up to you to either use the script, not available for this scenario with different operating systems, or you will manually copy the SUM directory from Windows to the target Linux, the complete SUM directory at this point in time. Well, obviously, there are some executables from Windows which do not fit to Linux. So afterwards, you will have to extract the respective SUM archive for Linux over the SUM folder that you've copied. Then you have the executables that you can run for Linux. And the second part is that you will consider those 2 sync points. That means you run the software update manager in the source. You can already start the one in the target. And there are 2 dialogues where you manually copy the content of the SUM ABAP load directory to the target. That means on those additional 2 sync points, the operating system is no longer relevant. There are control files, there are dump files that are being transferred, and they are understood by Linux and Windows. So that will be no issue then. It's just that for this combination with the standard, you cannot use for different operating systems this delivered script, but nevertheless, parallel mode is possible and strongly recommended. Thanks for asking.
Okay, thank you, Boris. And we have the next question in the chat. Do you know if all the downtime optimization techniques are available when moving to RISE S/4HANA Private Cloud Edition?
Good question as well, as we have this slide here saying, well, the DMO with system move is especially relevant if we move from ERP on-premise to SAP S/4HANA Cloud Private Edition, so the on-premise edition running at a hyperscaler. Then we have to use DMO with system move. And DMO with system move does not allow downtime-optimized DMO. It does not allow downtime-optimized conversion. So we have the strong recommendation to use the parallel mode for DMO with system move. But those advanced technologies that I've listed in the 3rd section, downtime-optimized DMO, downtime-optimized conversion, they are not supported for DMO with system move. Nevertheless, please consider the second link here. That is DMO conversion to hyperscaler. That is an approach not yet available, but there we try to use the plain DMO even for this combined transition to hyperscaler and conversion. And if this would turn out to be fine, if we would be able to use the plain DMO for this combined transition to hyperscaler and conversion, then we may, in the end, again use those downtime optimization technologies, which is future, which is not a promise. It's a disclaimer here, but this is where we are going. But again, your good question is DMO with system move is the current approach to be used for targeting S/4HANA Cloud Private Edition, so in the context of RISE. This does not support the advanced downtime technologies like the downtime-optimized DMO and downtime-optimized conversion.
Okay, thank you very much. I can't see more questions in the chat. Let's give you more seconds. Again, thank you very much, Boris, for your presentation. We continue our SAP Cloud Lifecycle Management webcast series. I'm also posting the announcements for the upcoming session either via the LinkedIn channel or here in YouTube channel of the SAP community, so stay tuned. With this, again, I see those who have stated the question saying thanks, which is great. And thank you for keeping the interaction live. With this, again, I would like to close this session and end the stream for today. Hope to have you in one of our upcoming sessions. And of course, stay tuned to SAP community news and sessions on various topics. With this, thank you very much and bye-bye.
Thank you. Bye.